Okay, we are looking at the function in our post task of drawing hyperbola graphs. We can write our function y equal to 4 over x. Our first task is to obtain a table of values given the x values in the table from -3 right up to 6. Remember, we do not need to calculate all the values on the table, as a few values that will show us the spread of the points are sufficient to draw the graph. So let's look at the first x value, which is x equal to -3. I'm going to substitute this value into my function y equal to 4 over x. So I'll get y equal to 4 over -3. And if I simplify this as a fraction, this will equal to -1 and 1/3. So my value for y is -1 and 1/3. Likewise, I will substitute x equal to -2 and obtain y equal to 4 over -2, which we know is equal to -2. So my value under -2 is -2. Now I'm going to give you a few minutes to complete the table for values of x from -1, 0, 1, 2 and 3. Let's see that you get those values. As you obtain the values by your calculation, you need to write these values onto the table that is provided for you. You would start with x equal to -1, x equal to 0, x equal to 1, x equal to 2, and x equal to 3. I'm going to give you a few more minutes to complete the table so that you obtain the values on your own, as the example I have pointed out to you. Remember that the domain of our function is all the possible x values, and our range for the function would be all the y values that satisfy the function. Right, have you obtained the values? Let's check them. So when x was equal to -1, y would have been equal to -4 over -1, which is -4. I'm filling it in the table. When x is equal to 0, this needs special attention. What do we know about 4 over 0? We know that does not exist in our real number system, so it is undefined. So we can put the undefined symbol there. When x is equal to 1, you would have obtained 4. When x is equal to 2, y is equal to 2, and when x is equal to 3, y is equal to 1 and 1/3. Okay. Now that you've got a spread of values for your table, your ordered pairs if you look at your ordered pairs, you've got minus 3 and y equal to minus 1 and 1/3. So plotting that value on your table on your graph sheet, the Cartesian plane, you would see that when x is equal to minus 3, y is equal to minus 1 and 1/3. If you follow the dot, there's minus 1, there's minus 2, minus 1 and 1/3 would be just below minus 1. So there is our point there. Our next ordered pair we're going to plot is x equal to minus 2, y equal to minus 2. So our second ordered pair that we got there, you can use the lines of the graph, the horizontal and vertical lines, where they intersect. You would plot the value minus 2 for x and y correspondingly to minus 2. When x is equal to minus 1, y is equal to minus 4. So there's our next value, x equal to minus 1, y equal to minus 4, and there's our point there. So you would see that we've got the values in a curve appearing like that there. We know that when x is 0, y is undefined, so we cannot plot that point. When x is 1, we'll obtain y equal to 4. When x is 2, y is equal to 2. When x is 3, y is 1 and 1/3, so 1 and 1/3 will be just above 1, which will be a point there. Okay, now what we are going to do is we are going to join the points to obtain the graph for this function y equal to 4 over x. And if I draw the points, I find that I obtain my function that appears like that there in the third quadrant, and in the first quadrant we've got these points here. So there we have our graph y equal to 4 over x. Well done. Okay, now we need to answer the questions based on the graph that you have just drawn. I'm going to help you along with this graph here. If you look at the first question, it asks you what is the domain of H, right? Okay, so let's look at the first question based on the graph H. We are asked what is the domain of H. From the graph before you, you can see that the values of x that we are considering are all values of x except 0. So we can now say that the domain of H would be what values? If you say yes, correct, x element of real numbers except x equal to 0. That would be the correct response there. In question B, we are asked to give the range of H. Okay, so look at your graph carefully, and now think about what are all the possible y values that are part of this function. If we look at it, we can see that we are considering all the negative y values, all the positive y values, again except y equal to 0. So our range is y element of r and y not equal to 0. Right, so we've got the domain and we've got the range in terms of our function. In question C, we are asked to write down the vertical asymptote. Remember, the vertical asymptote is the line or equation to which the graph comes close to but does not touch the graph or that line. It is, like we say, like an electric fence. From this graph we can see clearly that the y-axis is vertical and the graph grows close to the y-axis, but it will never touch the y-axis. So we can write the vertical asymptote as being the y-axis, or in equation form, which is more correct, we would say that x is equal to 0. So to repeat, our y-axis is the vertical asymptote. Remember, vertical asymptote is looking from bottom to top. That would be your vertical asymptote. Now we want to find our horizontal asymptote. If we look at our graph, we can see that the function comes close to the x-axis, which is the horizontal asymptote for this function. So our horizontal asymptote is the x-axis, or the equation is y equal to 0. So we have the vertical asymptote, we have the horizontal asymptote to the function y equal to 4 over x. In part D, we are asked what are the equations of the axis of symmetry. Remember, these are equations to which the graph is reflected about the axis of symmetry. So if we look at our function, we can see that if we draw a line through the origin, we have our line y equal to minus x being one line of symmetry. So we have y equal to minus x. As you can see, the graph is reflected about this line y equal to minus x. And we also have another line of symmetry, which would be the graph equal to y equal to x, the red line. So we have the equation y equal to x also being our axis of symmetry line. So to recap, y equal to minus x and y equal to x are the two axis of symmetry lines that we have for this function. The a value we can see that our A value is equal to positive 4. And in which quadrant does H lie? It lies in quadrant 1 and in quadrant 3. Okay, so we have completed drawing the sketch of y equal to 4 over x and answered the questions on that function. In your next task, you would be asked to draw the graph of y equal to minus 4 over x, and you need to observe what is the difference between the two functions that you have drawn. Note, as you draw these functions, you must observe in which quadrants they are found and see what effect the A value has on the function as you proceed. You need to see the effects of A on the function, whether it's positive or negative, and how does this affect the graph in terms of its quadrants. What effect is there in terms of the axis of symmetry and in terms of the asymptotes. Let's now proceed to the next function.